Hello dear students, welcome to Pen and Paper Chemistry, where we deal with the different aspects of chemistry: organic, inorganic, physical and general chemistry. And the only requirement for you to attend lessons on this is to keep a pen and paper, that's a notebook in your hand, so that you can have some good notes for offline reference and a good practice session as well. So are we ready to go as we continue with the properties of aldehydes and ketones in this, and this is part 3 of the set of videos. Nucleophilic addition followed by elimination, also known as condensation reaction, because a small molecule is formed as a side product in these reactions. In order to make these reactions easy, what if you can notice, we've got this flow chart made easily. You can also call them as mind maps. So these are made in order to help you to write the reactions. How do you think this flow chart is going to be helpful? Just wait and see. So let me explain first the fundamental. So when we talk about nucleophilic addition followed by elimination, so what is happening over here? We've already spoken about nucleophilic addition in the previous video, so I would request you to visit that and to go through that before you go ahead with it. So we've got a carbonyl here, negative, positive, and the positive goes to negative, the negative goes to positive. So what happens over here? We have a tetrahedral addition product, which is unstable and has a tendency to lose a water molecule from it, right? With the result, we will have the final product as double bond N and Z. Now, what is the Z that we've got over here? It's nothing but some other atoms or groups which are attached to the nitrogen. These type of reactions are taking place with ammonia and its derivatives. Yes, already written. So what are those derivatives? The first one is ammonia itself, of course. Then is primary amine. So we start with NH3. Remove the hydrogen by an alkyl group. I have a primary amine. Remove the alkyl by OH group. So I'll have hydroxylamine. Instead of OH, if I put another NH2 group, it becomes hydrazine. Replace the hydrogen by a phenyl group. So we will have C6H5NH2. So it becomes phenylhydrazine, right? Phenylhydrazine, sorry. So now coming to the last two parts, 2,4-DNP, 2,4-dinitrophenylhydrazine, very long name, right? Don't worry. In short, it is also called as Brady's reagent, and this is the one which is used to test carbonyl compounds in the laboratory as well. In short, we are calling it as 2,4-DNP or 2,4-DNPH. What will be its structure? Let's draw the structure of phenylhydrazine first. Okay, so we will have here phenylhydrazine, right? So NH, NH2, as simple as that. Now we've got 2,4-dinitro, so that means I will have 1, 2, 3, 4. Yes, it's easy, correct? So at the second position you have a nitro group, and at the fourth position you have a nitro group, and you have the Brady's reagent. That means 2,4-dinitrophenylhydrazine. Semicarbazide is again taking from the urea. So you can take it as a phenyl derivative of urea. We will have it as C6H5NH CONH2, semicarbazide. Now you must be wondering, how am I going to write the reactions for all of them? It's going to be pretty tough, right? No, don't worry. Everywhere, what we are going to do is, we are going to take H2 separate and the remaining molecule we are going to write as Z. Easy? So this is what I said. What we are going to do is, C double bond O is here our carbonyl compound, H2 separate and Z. That is the nitrogen derivative. Next step is simply remove a water molecule, and next step is C double bond NZ. Yeah, I think I forgot the nitrogen over there. Sorry for this. So we will have H2 and Z. Z is the remaining part. So here, for example, it will be H2NR. Here H2NOH. Again H2 and NH2. Right? I'm giving you hints over there. Come on, try writing the reaction yourself. You'll enjoy chemistry much more. An important point to be noted over here is that the ideal pH value for these reactions is around 3.5. What is the role of acid? We spoke earlier as well. What does the acid do is, the hydrogen ion of the acid actually protonates the oxygen, and it helps to increase the electrophilic character of the carbon atom. If the pH is higher, that means your solution becomes more basic, then no protonation happens. On the other hand, if the pH goes lower than 3.5, that means the solution becomes very acidic, then in that case, we will end up getting ammonium salts in the solution, right? Because we are using amines, ammonia derivatives over here. A term we are using over here is condensation reactions. Why are we calling these as condensation reactions? Because you notice that after an addition product is formed, a simple molecule like water is eliminated from here. That means it is being released during the process of this reaction. Such reactions are known as condensation reactions. We have also discussed this as part of, again, a separate video, types of organic reactions. In case you are lost in any of the terms, there are a lot of videos loaded on this YouTube channel, and you will also find notes on pen and paper Google site. Yes, it's a Google site. So if you just Google pen and paper chemistry, oh, why do I forget the chemistry bit every time? Pen and paper chemistry, it's a Google site. You will get these flowcharts, easy to download. You will find lots of notes also, which you can easily download. So let's get started. First is reaction with ammonia. I'm going to write the general reaction, C double bond O plus NH3. So what are we going to do? We are going to switch it around and we are going to write it as H2NH. Go ahead, write the products. Remember the box and then simply C double bond NH, and the substituted product is known as an imine. You have to write the same reaction with methanol, ethanol and propan-2-one. I leave it for you to complete this. Next is with primary amine. So again, what am I going to do? Take the H2, take the N and the R. So you get substituted amines. Again, write the reaction 3 times. Now I know it can get very boring, especially if you are a student who's already covered the topic and are visiting the channel only for a quick revision. But believe me, it really helps to give you a firm base, and it really helps to embed the concept. So go ahead. Sometimes it is fun to do easy things as well. Gives you the satisfaction that you've done something. Correct? Go ahead, complete the reactions, and don't forget the acidic conditions of the reaction. Hydroxylamine, again H2NOH. These are usually known by their common names only. So if you see in the flow chart, we've called them as oximes. So it would be methanol oxime, ethanol oxime, or propanol oxime, and so on, right? So you don't worry too much about the IUPAC nomenclature. Just put the name of the compound before oxime. Right? So from hydroxylamine you're getting oxime, from hydrazine you're getting hydrazone, and so on. With hydrazine you get hydrazone. Go ahead, complete the reaction. With phenylhydrazine, again what are you going to do? C double bond O plus, take the H2N, NH, C6, H5. That's it. Just take away the water and connect the two by a double bond with 2,4-dinitrophenylhydrazine. Again, a very important point over here is that carbonyl compounds give you a yellow, orange, or red PPT, which helps us to identify this set of compounds. Again, if you want to draw the structure, C double bond O, I will go by the same route. So I have phenylhydrazine, right? So NH, NH2. Now I want to take away the water. So what I'm going to do is I'll put my, this may look very long and difficult, but believe me, once you've drawn, you'll really enjoy learning it. NO2, NO2. Now simple. Just remove the water and connect the nitrogen to the carbon. Isn't it easy? Semicarbazide, again H2. I leave this for you to do. Go ahead, try it yourself. Now that we have covered the nucleophilic addition and the nucleophilic addition followed by elimination, this is the complete flow chart for you to note down and to make it on an A4 size sheet, or you can take an old calendar and make the same flow chart on this. But don't forget, there are more properties on their way. So we'll be talking about oxidation, reduction, polymerization. So make sure that you leave some space down in order to add more reactions and more properties of aldehydes and ketones. Till the next video, take good care of your health and keep smiling. Don't forget to share. See you soon.